My name is Kyle Hecker, and this is IQE number 2 for Fluids 307. The first conceptual question is, a mass balance equation can be written for control volume as m in minus m out equals delta m. Which processes below can the mass balance equation be used for? The process options are a steady flow process, an unsteady flow process, an adiabatic process, or all the above. For this equation, the mass balance equation, all three of these processes are able to use this mass balance equation. For the calculation question, the question states a propeller plane is being tested in a wind tunnel with wind at 150 meters per second, and the diameter of the blades are 2.5 meters. What is the mechanical energy of the plane, and how much power is the engine outputting? Density of air is 1.2 kilograms per meter cubed, and this came off the conversion factor sheet. So, to start with the K-FAPS format, the known values are velocity, which is 150 meters per second, density, which is 1.2 kilograms per meter cubed, and a diameter, which is 2.5. This should say 2.5. Boom, 2.5 meters. That's a diameter. What we need to find is mechanical energy and the engine output power. What we're able to assume as far as Bernoulli's equation goes is that pressure equals 0 and height equals 0. So in turn, we'll be able to use this simplified Bernoulli's just to get velocity. And then the properties is just the rho, the density of air. So to start, the mechanical energy, we get to eliminate these two terms and then just solve for the velocity by squaring it, and then have to do this conversion to get it to kilojoules per kilogram. Then, in order to get power, we have to do a couple steps. First, we have to get volume by doing the cross-section area times the velocity, and then the area is pi r squared, so this r is the radius of this diameter. Squared times pi times the velocity is 736.31, and then to manipulate the rho equals m over v equation, we get this m dot is 1.2 times the volume, which gives us 883.57, and then we get to multiply this number times the mechanical energy in order to get power, as you get kilojoules per second, which is a kilowatt, and we end up with around 9,940 kilowatts for the engine output power.